Here we go. Welcome to everybody once again. Insider's Guide to the Galaxy with Chris Vaughan and me in the background, Charles S. We're just going to let some people get in here. We're going to be doing a presentation today on the moon, supermoons and stuff.
So yes, hello everybody. Welcome to August. I'm declaring August Moon Month because we've got a full moon, supermoon tonight. And then towards the end of the month, we've got another supermoon and it'll be a blue moon. So what we're going to do is talk about full moons, supermoons, blue moons, and some of the things the moon's going to get up to over the next little while. If I have time, I'm going to share a bit of a PowerPoint on some specific things to check out on the full moon. So, and maybe some advice and things like that. So we can get started. Let's start with a little bit of basics. So the moon has an elliptical orbit around the Earth, and the period of that orbit is 27.32 days. So we call that the sidereal period. That's the time it takes for the moon to come around and kind of face the same direction in the universe again. And because of the elliptical nature of the orbit, then the moon spends one point of its orbit closest to the Earth in that orbit, and then at other times farthest from the Earth in its orbit. So the closest point is the perigee, and the farthest is the apogee. And the way I remember that is I think apogee in a way at the start with the same letter. So that's how I do it. I don't know how everyone else does it, but that's apogee. The range varies by, on average, 362,400 kilometers at the near end, and then about 405,400 at the far end. So it ranges by that amount. And when the moon is closer to the Earth, closest to the Earth in its orbit, it looks about 14% larger than at the other extreme, give or take, depending on a few other things. So I'm going to show you actually an animation. Let me just share my screen and bring up an animation here that kind of explains what's going on here. So if you could stare at the moon 24/7 without the sun coming up, without the Earth under your feet getting in the way, this is what you'd see. This is from Wikipedia. And you can see a couple of things happening. So you've got the phases of the moon happening in fast forward time. You've got the size of the moon's disk swelling and shrinking due to that apogee, perigee, closer and farther effect. And then you've also got the moon nodding up and down and turning its head left and right, if you want to think of it that way. And that nodding and, yes and no motion on the moon, that's called libration. That's also caused by the moon's orbital tilt by about 5 degrees from the ecliptic. And also the moon's elliptical orbit means it travels faster and slower at times. And because the moon is keeping its same face towards the Earth at all times, it's rotating at the same rate that it's orbiting. But when it speeds up and slows down, the face sometimes doesn't keep up. And so we're seeing either cheek. And that's why you get that east and west pieces of the moon showing up. So I'll just leave this running while I share a few more things. So the moon phases, they repeat on a slightly different cycle. That repeats every 29.5 days. And that's because we're seeing those phases on the moon from a moving platform, and the sun is doing the illuminating of the moon. And since we're moving with respect to that illuminator, the sun, then that changes the time it takes for the phases to repeat. It increases it by a couple of days. And so about every, that period, by the way, is called the synodic period. And have you ever heard the term the synod as meaning a group of people? The word synodikos, I think is a Greek word. It means a conjunction of people or celestial objects. So that's the synodic period of the moon, the phase repeating period of the moon. So bottom line, about every 14 lunations, which is a lunar month, the two cycles temporarily kind of line up or synchronize for 3 or 4 months. And that gives us the opportunity for the moon to be full while it's closest. And that's what we call a supermoon. So the astronomers don't put a lot of stock into the supermoon jargon name, but technically, if you want to get technical, it's a lunar perigee syzygy. So a syzygy is when celestial objects line up in a line. And so when the sun, earth, and moon are in a line, that's when you get a full moon. And so that's a syzygy. And when it's closer to the earth, it's perigee. So it's a perigean or perigee syzygy, or supermoon for short. Now, don't forget that while that sort of synchronization is happening with the full moon, we also get new moons that are happening while the moon is at apogee. So they're kind of little micro new moons. And if we happen to get a solar eclipse during that one of those alignments or setups, then the moon is not large enough to cover the sun. So it tends to be an annular solar eclipse. So when you see an annular eclipse, it tends to be because of that sort of thing. Let's see, what else? Some people call those micromoons. You can also have a mini moon or a micromoon when the moon is full while it's farthest away as well. So again, now where did all this come from? So the stories that you'll read if you go looking for kind of information about supermoons is that an astrologer by the name of Richard Knoll published an article in 1979 where he had been reading some almanacs, some information about the moon's size changes and things like that. And he decided that when the moon is full while it's within 90% of its closest distance to the Earth, then we can call that a supermoon. And he's updated his approach or his definition since then. But basically, that's kind of the idea. And places like Sky and Telescope magazine or timeanddate.com, they kind of want to be able to be scientifically rigorous about these things. So they've actually come up with a range of distance. So Sky and Telescope, I think, are using, if the moon is full when it's within 358,884 kilometers of the Earth, I'm not sure if that's the center of the Earth or the surface of the Earth. I didn't look that up, but it's considered super. And Time and Date rounds that up to 360,000 kilometers. And the funny thing about that is that when the moon is kind of marginally super, then if you live near the tropics, you're technically closer to the moon than if you live at high latitudes. So the moon could be super in the tropics and not super at higher latitudes. So that's kind of funny. Last month's full moon, was called super by some sources and not super by other sources. And it was mainly because of that, because in some places of the world it was, and others it wasn't. So supermoons, they get people out looking up. That's fun. That's fine. They're not all that super, particularly. The moon will look about 7% brighter than average. I said the size changes by about 14, but from an average moon to super is about half of that, or 7%. But the moon will look brighter by up to about 16% brighter, and that's because of the inverse square law of light. The increased distance or decreased distance makes the light more amplified, so it's brighter. Supermoons will give you higher tides, perigean tides, but even though some people have tried to claim that supermoons can trigger, seismic events or other things in the Earth itself, that's pretty much debunked. It's really not much more effect than extra tides, a few inches of extra tide bore during a supermoon. And a lot of people wouldn't even know it was a supermoon, unless the media were not to promote it. So today, right now, actually, or about half an hour ago or an hour ago, the moon reached its official full moon phase. It was, I think, 2:32 p.m. Eastern time when the moon was full. So that means when the moon rises for us in Canada, it'll already be some hours, past its official full point. Folks maybe in, I'm not sure if it's the Middle East or Eurasia. I mean, they are getting to see the full moon rise when it's full, but the rest of the world, moon phases occur independently of Earth's rotation. So it might be up when it hits that phase, or it might not be, in which case you've got to wait. So the fact that the moon is full on Monday afternoon means that in North America or the American hemisphere, it's going to look full tonight, and it also looked pretty full last night if you're out, and it would have been super-ish on both evenings. So let's see what else I want to say about that. This moon is fairly super as that goes. As I said, the July one was on the margin. This one is closer, so it's more super. And then the one on August 30th will be the largest, closest full moon of 2023. So it'll be the superest, if you want. That'll be, I think I've got written down. So the typical full moon is about 32 arc minutes in diameter. This one tonight is going to be almost 33 arc minutes in diameter, and the one in August 30th will be about 33 and a half. And then looking beyond that another month, we've got one more supermoon at the end of September. So that's our kind of sequence of 3, 4, depending on whether you live in Florida or not. You want to kind of put it that way. Any questions on any of that come through so far, Charles?
No, I was going to say the way I figure out apogee is the letter A looks like the peak of a mountain, so that's as far out as it goes. And what I like to tell people is the difference between a regular full moon and a supermoon is sort of like the difference between a 12-inch pizza and a 12-1/4-inch pizza. It's not really that much bigger.
Yeah. Everybody's got all the people that do astronomy outreach all have their favorite comparators. Yeah. Cool. All right, let's press on a little bit then. Before we went live, well, earlier today I was on the radio for a drive home show in Mississauga, and they asked me, why are people calling this the full sturgeon supermoon? Well, we've already covered why it's super, and we've already covered why it's full. The sturgeon part comes from the various nicknames that people have assigned the different moons that occur, different full moons that occur at different months of the year. So the sort of common farmer's almanac sort of words or names for the full moon that happens in August include the sturgeon moon, the red moon, the green corn moon, the grain moon, and these are all kind of meant to suggest things that are happening in nature around that time. I'm not 100% sure what the red moon refers to, but often it refers to certain plants that are blooming or growing things that are maybe have a red color that you see in the forest at that time of the year. Of course, all the indigenous peoples in North America that we're most familiar with, but also around the world, they all have their own nomenclature for the full moons. Full moons have been with humanity since the beginning. So I'll note a few of them here. I don't know if I'm going to do very much justice to the names here, but the indigenous, the Anishinaabe people of the Great Lakes region, they call this Manuminike Geezes. Geezes is their moon, the word for moon, or the wild rice moon. They also some sects or groups call it the Menine Geezes, or the blueberry moon. The Cree, they call it Opahawipisim, or the flying up moon. The Haudenosaunee call it the freshness moon, and then the Mi'kmaq of the Canadian East call it the berry ripening. So, and Charles, I'm sure you've got loads of different names as well. There are websites you can find where social studies experts have listed all kinds of different cultural names for the moon as well. Do you have any favorites?
Lunar calendars that don't sync up with the solar calendars, so they're to use them, you've got to have an extra piece that you put in to get them back in synchronization every so often, and all of those pieces have a name. Yeah.
When I do my my Skylights blog and I'm covering the full moon, things like August, which we'll come to in a second here, where we do have a second moon full moon happening within August. Typically you use these common farmer's almanac names for the first time, and then use the blue moon to cover off the second. But I know the Mi'kmaq moons, they actually have ranges of dates that the moon falls within to assign that particular name. And again, that ties exactly back to nature and what's going on in nature. So yeah. All right, so I've actually given Charles some links that he can share with some really nice in-depth articles on some of these topics. Sky and Telescope magazine are great for posting some of their material online. So there's some neat material in there. So let's talk about the blue moon that's going to happen later this month. So if any lunar phase happens in the first day or two of a calendar month, except maybe February, then there's time for it to repeat by the end of the month. And so sitting here today on August 1st, we've got a full moon tonight. That means we're going to get another full moon on August 30th. And that's colloquially become called a blue moon. Now, from my research, it seems that there have been references to the blue moon in the sense of a rare event from dating in literature going back a long ways, you know, kind of before astronomy got really codified. But obviously the moon's not going to look blue unless something else is going on to tint it. But we use that expression once in a blue moon to express the idea that something is rare. But it isn't all that rare. I mean, we get a blue moon in this sense of 2 in 1 calendar month every 2 or 3 years. And as I said, they don't look blue, so don't expect it to look blue. People misunderstand. So there's an older definition though, and this sort of comes back to Sky and Telescope again, and in one of the articles that I gave Charles the link for. So a magazine or a publication called the Maine Farmer's Almanac, since the 18th century, had been publishing the dates for the blue moons. And I think the idea behind that was in order to alert the farmers when they would have more light in the fields, right? They want to be able to, they can work later at night when they've got extra moonlight. So it's a bonus for them to have an extra moon to do some of their work on it. So the Farmer's Almanac defined the blue moon as the 3rd time the moon is full in a season containing 4 full moons. Now, you know, in astronomy or in most times in modern times, we express the start and end dates of seasons by the motion of the sun along the ecliptic, position of the sun along the ecliptic. But under some definitions, you can just imagine that the sun is traveling at a steady rate, even though it's not, because Earth's orbit is elliptical. And you can sort of lock in the beginnings of each season. So rather than it drift, say, from March 20th to 22nd for the first day of spring, just call it March 21st every year. So that's called a tropical year. It's called an equal season model. And the Maine Farmer's Almanac was using this equal season model. So it was easy to say the moon there's 3 of them in this set of this season, and there's otherwise 4, you know, whatever it was. But the trick is that because people tended to give names to the moons that are linked to the seasonal changes, because things like the moon controls the timing of Easter and Passover and some of the cultural festivals. So you wouldn't want to take the Lenten moon or the Paschal moon or the Easter moon and call it the blue moon. So the way you get around that is you make sure those moons always stay the way they are. Same with the moon before Yule and the moon after Yule. And since the Yule and Easter tend to be linked to the solstices and equinoxes, you're safe if you tuck that extra full moon into the 3rd position of the 4. So you're not typically going to be interfering with any of those other, you know, moons that are used for religious purposes or cultural purposes. So that's why their definition was the 3rd moon out of 4 in a season. Now, where Sky and Telescope comes into the picture is that at some point, astronomers working or writing for Sky and Telescope thought they would kind of highlight this phenomenon. And they did some research on the Maine Farmer's Almanac, and they were trying to figure out, they didn't actually contact the people to ask them what their rules were. They just sort of inferred what the rules were that they were using by the blue moons that they were seeing in the pages of the almanac every year. And unbeknownst to them, they kind of had a limited data set, and they said, well, this looks like it's just the 2nd moon in a calendar month, so that must be it. And that's what they published. So there's a gentleman by the name of James Hugh Pruitt. So in March 1946, he published an article in Sky and Telescope magazine talking about blue moons, and he said, they're the 2nd moon in a calendar month, and it stuck. And so that's what most of us have come to use to this day. But so you've got different definitions. Here's another courtesy of Sky and Telescope. Here's another kind of sketch. So you can find this on this link here if you want to grab it off the video or take it from what Charles can put in the chat. But here we've got 2020 down to 2040. And these are the columns of the months of the year. And you can see here we are in 2023 with August having a blue moon. Now, our August 30th blue moon is blue by both definitions. So it's a true blue, genuine blue supermoon. So that's fun. Any questions in any of that stuff?
No questions so far. Just remind everybody you can put it in the chat or you can put it in Q&A and we'll pass it on.
All right, let's take this off here. And let's look at the stellarium. So this is the stellarium for the latitude, basically the latitude of Toronto, if you want to think of it that way. And now we're going to talk about observing the full moon and what you can see on it and things like that. But the first thing you've got to think about is full moons that happen in July, August, June, July, August, basically. They don't get very high in the sky because the moon is kind of near the ecliptic and the sun is at high noon in the summer months. That sort of teeter-totter effect keeps the midnight, the full moon at midnight, rather low in the sky. So you can see here on my stellarium, I've got, I'll just bring this into later at night. You've got the orange, yellowish line here is the ecliptic. So the moon, because it has that 5-degree tilt from the ecliptic, it sort of rides along the ecliptic towards from west to east, but it'll rise and fall up to 5 degrees below and above the ecliptic. So first of all, the ecliptic at midnight in the summer months is especially low in the sky. In fact, I think I can put on the, let's see if I can do this, the celestial equator. There it is. So there's the celestial equator, which stays at the same spot for your latitude at all times. The ecliptic is well below the celestial equator during the summer months. Plus, for the next number of years, the moon, the full moons in summer are going to be at their southerly declinations below the ecliptic. So a few days ago or last month, we were doing outreach and we were saying, there's the full moon, or there's the moon sitting right beside Antares, which is crazy. We're all used to thinking of Antares as being this low on the horizon constellation. There's the moon sitting between the teapot of Scorpius and Antares, and that just sort of brings it home how low it is in the sky. So the long and short of that is that when the moon is lower like that, it's going to be less clearly seen through telescopes and binoculars. So while the moon is a great thing to look at in the summer months when the weather's nice and everything's great to be outside, maybe with a beverage on the deck, the moon from an astronomy point of view maybe is not the best time to see it because it's rather low in the sky. It's going to be low like that. I think I looked, because the moon's orbit kind of evolves in a cycle over time, it's going to be low like that till about 2028. And then the summer full moons are going to be more closer to the ecliptic a few degrees higher in the sky. So when you are looking at the moon, and by the way, the December, the winter, midwinter full moons, they're where the sun is now in the summertime. They're high in the sky, beautiful conditions for seeing through the least amount of Earth's atmosphere. So if you can stand the cold, you're going to get beautiful crisp views of the moon in the winter months. And then of course, spring and summer are kind of in between. So they're great times as well. So no problem. It's always a good time to see the moon. So what can you see through a telescope when you're looking at the moon? Here's just some rules of thumb. So first of all, if you've got an 80mm telescope, which is a good beginner-sized telescope, you can resolve features on the moon that are about 1.8 kilometers in diameter. So that would be the smallest crater you could see, or the smallest mountain peak, things like that. If you bump it up to say a 6-inch telescope, then you can basically almost cut that size in half. You can see an object that's a kilometer across. If you've got an 8-inch telescope, lots of folks have 8-inch Dobsonians or Schmidt-Cassegrain telescopes, you're going to get down to an 800-meter size feature. And really, there's nothing on Earth really that's going to let you see, the lunar modules or any of the stuff that the Apollo missions left behind. So, don't even try. The way we get to see those remains, footprints, moon buggy tracks, the flag laying on the moon surface. For that, you need a photograph from an orbiter flying over the moon or orbiting the moon. So yeah. Now, if you my advice, if you want to look at the full moon is kind of like, for most, it's the least favorite time to look at the moon because all the sunlight arriving on the full moon is coming from behind you towards the moon. So it's arriving kind of vertically from above the lunar surface, and therefore it's not casting very many shadows from features on the lunar topography. And that tends to flatten out or make it look a little dull looking. The benefit, though, is that the variations in brightness that you're seeing on the moon at that time are not due to shadows anymore. Now they're strictly due to the lunar geology. So you've got, the different tones of rock color are actually representing different geological units and different geological rock types. The white areas are the anorthosite, the sort of crystalline, bright colored rock, and the dark areas are iron-rich, heavy, dark-colored basalt rocks. And we have basalt rocks of similar composition on the Earth as well. So I actually have a piece downstairs that I picked up on a mountaintop in British Columbia. That's I always pretend this is kind of what a moon rock would be like. If you find the full moon bright, which we all will, I mean, if you're planning to look at, a few stars, maybe double stars, and the moon on the same session, the full moon on the same session, save the moon for last. Because if you try to look at the full moon first, your eyesight is going to be completely overwhelmed and ruined by the bright moonlight. Unless you put something like a neutral density filter. So you can actually put a filter on your eyepiece. Or if you've got a telescope that's got a sub cap, some telescopes have a big lens cap and then a smaller opening that you can use. You can use that stop down aperture to diminish the brightness of the moon. But actually, you can even put sunglasses on, frankly, if you're watching the full moon, if you don't have a filter. The other advice is you want to use high power if you want to see the small features. RASC has lunar observing programs. There's lunar features in the Explore the Universe program. There is a binoculars program, which a lot of the features on you can see even with your unaided eyes, but as well clearly through binoculars. And then there's the telescope program, which is about 90 or 100 objects to see. But if you want to do the Isabel Williams Lunar Observing Program, which is upwards of 700 objects, you're looking at tiny things. And for that, you're going to need to use very high magnification, and you're going to need the seeing conditions to be good. You want the air to be steady because a number of things are going to be hard to spot in a blurry view. So those are some basic advice. I'll pull up in a minute some things to look at on the moon, but I'll stop for a second and see if, Charles, you have anything to add or any questions.
Yeah, we have a question on line here about a link for a place that tells you about the various different named moons, and I threw one on there, which is time and date. Do you have any that?
I don't have it at hand. There was a researcher in the US that had a website with a very lengthy list of all the different full moons for different indigenous groups, including Central America, all kinds of other places. I think you'll be able to find it if you kind of search with the right set of words. You'll pick it up. Yeah, good question though. Anybody else?
It looks like everything we got at the moment.
All right. So I put this PowerPoint together a while back for one of the RASC centers to talk about my adventures looking at the moon. I'm not going to go through the whole thing. I'm just going to highlight some bits and pieces on it. So for anybody that wants to head out tonight and just look up and enjoy the big bright moon, the supermoon, don't forget that you can always cover that supermoon up with the tip of your pinky finger when you close one eye and put your arm at arm's length. And that'll work if you're an adult, and it'll also work if you're a youngster, because the little fingers and shorter arms work together to make that work. So that's fun. When you're gazing up at the moon, as I said, you've got your bright areas, your dark areas. So the bright areas are the original lunar crust, heavily bombarded, heavily pockmarked. The darker areas are basins that were excavated, bowl-shaped basins that were excavated early in the moon's history, and then later infilled by upwelling dark, heavy rock from the interior of the moon. And that's made them both darker and also younger or less kind of scarred, less pockmarked. And then you've got all kinds of places where fresher, younger craters like Tycho here is prominently visible, and certainly in binoculars, perhaps with your sharp unaided eyes too. And you can see these rays, these streaks of both ejecta that were blasted out of the crater when it was formed, but also a lot of those rays are produced by chains of craters that are the secondary impacts of the debris falling back to the lunar surface in a line radiating away from the crater. So Tycho has this great set of rays that extend for thousands of kilometers in all kinds of directions, but not in every single direction. So one of the neat things about Tycho is you can see it here on this slide that the rays are missing to the lunar west. So that's an indicator that the impactor came in from the west and probably at a fairly steep angle, but the rays were missing from the western side. And you can play that game all kinds of places. I'll zoom in on a couple spots here in a minute. Up here into the upper left of the moon's surface, you can see the extensive connected section, which is the combination of Mare Imbrium, one of the biggest basins on the moon. It's larger and circular. And that connects with Oceanus Procellarum, which is also thought to be basically a circular basin, but it's kind of been overprinted by some of the other things that have happened since. And within those, you've got Copernicus and Kepler, and they have ray systems as well. You can see theirs are pretty symmetrical, shorter, and I tend to think of them as more raggedy, and I'm not quite sure why they're more raggedy than Tycho's more linear shaped rays. But if somebody has anything to add on that, they're certainly welcome to share that. So let's zoom in on a couple of things here. I think I'm not going to bother making these slides full. I'll just kind of let you all look at them as I share them here. You can see here that we've got a few of these blue labels that are representing some of the craters that are known to have rays. Anaxagoras here at the north pole of the moon, you'll see those rays like bangs kind of down the moon's forehead, if you want to think of it that way. And I'll zoom in here in a minute. So we've got up in the upper, sort of just a little bit north on the east side of the moon, we've got the Mare Crisium, the oval of Mare Crisium. And then lots of people know about this crater Proclus, which is sitting beside Mare Crisium. Let's just see if I can bring up a slideshow from the current. Here, let's do it this way. There we go. So there's Mare Crisium, there's the little Proclus. So the younger craters tend to be brighter. So Proclus is this little bright dot, and then you can see the rays kind of extending, missing this arrowhead because the rays on Proclus are actually asymmetrical as well. They're missing from the western quadrant. So maybe there's a pattern here where impactors are coming in from primarily from the west. It could be to do with the direction of the moon's orbit around Earth, that sort of thing. And if I give you a zoom up view, close up view, so there's a better picture of Proclus. This is a view of Proclus, kind of during a full moon-ish phase. So that's why when the moon is quite full, then the light tends to give you these bright looking craters, and the rays are more visible when the moon is close to full. So Proclus itself is 28 kilometers wide, and the rays are about 600 kilometers long and asymmetrical. Here's another one of my favorites to do when I'm doing outreach. So a lot of times, people ask me for a star party on a full moon night. And so I made it a point of figuring out what to show people on the full moon when I can't show them galaxies and nebulas and other things. So Mare Fecunditatis hosts the crater, the double craters called Messier and Messier A. And when the moon is full, they look like they've got comet tails, which is why they're named Messier. No surprise there. This is the same craters shown at a different phase of the lunar month. But these rays are about 120 kilometers long. And again, this looks like a really shallow impact, this time from the east, about 4 degrees above the horizon, so skimming over the lunar surface. Not sure if the object that hit was a pair of objects or something that split just before it hit or bounced. I mean, different things can happen to cause these sort of weird pairings. What else have I got? Dionysus. So Dionysus is a bright little dot crater here that's visible binoculars easily on a full moon. It's at the southwestern edge of this dark mare tranquillitatis. So this is where Apollo 11 landed, right where this number 11 is in red. And Dionysus is neat because it's got rays, but the rays are black instead of white. So this is something that's great to see in a telescope when the moon is full. And what's happened there is that you had dark underlying basalt, and then that got overprinted by some ejecta, whiter ejecta. And then later on, a crater came in and punched through that ejecta and excavated some of the gray, darker basaltic material underneath. So you've got a sandwich effect. So you're excavating some of the basalt on top of the ejecta blanket. So it's kind of a neat bit of history there. So that's one to look for. What else have we got? Dark halo craters on a full moon are neat as well. Remember I pointed out Copernicus. So Copernicus is really prominent, really easy to see. And if you zoom in on Copernicus near a full moon, you're going to see its rays easily. But if you zoom in all around Copernicus, you've got little craters that came in later and again punched through the Copernicus ejecta and brought up some of the underlying mare basalt to give you dark halos. So these little craters have dark rings around them. So you can see that I've marked a number of them here around Copernicus. So don't just be distracted by how cool Copernicus looks. Look around, look at some of the other neat things. All right, Alphonsus. So I almost always look at Alphonsus at the full moon when I've got my telescope out. It's fantastic. And the reason it's so cool, it's sitting here right near the center of the moon's disk. There's Tycho for reference below it. And I don't know what pattern you see when you look at the moon, but me, I'm stuck now with seeing Wilma Flintstone in profile. So I see Wilma Flintstone's eye, her nose, her smile, her chin, her throat. Tycho's her necklace. And right under her chin here is Alphonsus. And zoomed in, it looks like this on a full moon. It's got a triangle, 3 dark patches within the crater. Those are thought to be volcanic cones or cinder cones or volcanic events where something erupted and deposited dark material and stained the lunar surface. Under really high magnification, a lunar orbiter photo can show you the little caldera or the vent holes where the material came up, but this is basically the same triangle here. So it's a very old crater, about 4 billion years old. And they think that those craters are about 3.2 to 3.5 billion years old as well. Rich in iron, rich in titanium. And there have been reports, Gary Saronic among others, Gary actually took this photo, but there have been reports by some folks of seeing venting of gas out of these volcanoes. So it's another reason to take a look. I think I've got one more in here to take a look at. Yeah, Atlas. So above Tranquillitatis and Serenitatis, there are a couple of craters here that are quite easy to see without a big telescope in the northeastern quadrant of the moon. And that's Hercules and Atlas. Hercules has this bright, later, younger crater called Hercules G in it that makes it kind of distinctive looking, very bright. And then Atlas itself has more of those volcanic eruptions inside of that, so more volcanic cones. So those are neat ones to take a look at. Let's see, was there anything else? The Aristarchus region. So the Aristarchus region is sitting up here to the west of Copernicus. And again, I talked about that having a ray system, but under magnification, when the moon is not full, it's spectacular because the structures, the rill and the craters on that area are really spectacular to see under slanted illumination. But at the full moon, you might notice that it's actually tinted a bit brownish in color. And that's because there's something chemically different about this sort of diamond-shaped Aristarchus plateau. And orbiting probes have detected sulfur compounds. There's some radioactivity associated with the area. So take a note, maybe pick up that tint when you're looking at the moon when it's full. All right, I think I'll stop there. Let's just jump down here. I'll see if anybody had any questions so far.
Yeah, we had someone asking how old is the moon, and I answered that, 4.53 billion years. But they also want to know what caused the basins to form on the moon. leave that one for you.
Okay, well, I wasn't gonna do, let's see, got the lesson here. Let me open up the other one here. Do this. So first of all, we think the moon is probably made when something the size of Mars, maybe a little smaller, did a glancing blow of the Earth in the early formation of the solar system, and just kind of tore the skin off the tennis ball, if you want. And that Earth's crust skin that then formed a ring and coalesced into the moon. So the chemical composition of that moon is very close to the composition of Earth's crust as a result. But here's the, let's see if I can remember what I was going to say about this. So there's kind of the timeline of the moon from the formation at the bottom to the craters to the modern day. And you can see here that, let's see if I bring this up. Here we go. There was a period of heavy bombardment where all the leftover bits and pieces of the formation of the solar system consisted of quite a few worldlets, large hunks that were really darting around the solar system, trying to, everything kind of figure out where it was going to end up. And those objects were slamming into all the other objects, including the Earth, including the moon. And so those big pieces would have been what created the big basins. So excavated basically craters, giant craters that are hundreds to 1,000 kilometers across and producing that. And then I think on here, this is the period of time when the basins were being formed from about 4.2 to 3.7. So you can see these red stripes are meant to indicate the different basins being formed. And you can also see the relative age of the zone. So Imbrium is the one I mentioned, the big circular one. It's one of the newest or last. Oriental, which is on the very edge of the moon, which is we only see parts of it from Earth, and it's the youngest. And then after that came that period of infilling with the lunar volcanism, the dark lava filling in those basins. And then since then, that's the end of the process. So the Mare were first excavated and then filled in. And then from then we've had things like younger craters forming, Tycho, Copernicus, Kepler, all of these ray systems, Proclus, Dionysus. So yeah. And just to note that, the scale bar on this is a little bit funny because the Copernican, the current era, the craters with the bright rays, represent half the moon's age. So it's not a linear scale, this vertical bar. Does that answer the question? I hope so.
I think it does. Somebody's asking density of the Earth-side variations. I'm not quite sure what they mean by that.
Sorry, density of the
Earth-side variations. Maybe I'll ask them to expand that question. The next question is, what about the composition of the impactor as well?
Yeah, so the impactor that maybe formed the moon, I think people think it may have coalesced with the Earth. I think so. I'm not sure the dynamics of it. I think because we have such limited information about the boots on the ground for the moon, we can't really accurately analyze the history book of the moon until we get a lot more samples from a lot more places and maybe drill into it as well. So I think that's a bit up for grabs still, what's going to ultimately be the answer. But this cross section I'm showing you right now gives you a sense of the fact that the moon and the Earth are pulling on one another actually offsets the center of the moon's mass towards the Earth. So the CF is the center figure, the center of the spherical moon, and center of mass is offset towards the Earth on the side. So this is the near side of the moon. And you can see here that as a result, the core is all sloughed towards the Earth. And it means that the lunar far side crust is about 140 kilometers thick. And the moon's near side crust is about half of that. And when the lava leaked out of the moon, it leaked out to sea level. And, it's kind of ironic that we called them seas before we knew that they weren't water, but they did reach sea level in that sense. And so because the crust is shallower enough on the Earth side, those rock seas were accumulated predominantly on the Earth-facing hemisphere of the moon. So you can see the sense of that on this picture here. Yeah, all this is fun stuff.
We have someone asking, what is the best website for trivia facts about the moon because they need to create a presentation for York University about the moon?
Well, you can do what most of us do, and that's, read some books, go into Wikipedia. That's a perfect question, because what we're going to do next, let's see. We can skip ahead. Yeah, what we can do is we can skip ahead, and I can talk a little bit about my favorite moon reference material and apps. So let's do that. And then we'll circle back to a couple other things. So first of all, if you want to, I'll split this into in two things. So if you want to view the moon and understand what you're seeing, identify features, then that's kind of the lunar atlas side of things. But if you want to understand why things are the way they are and how things relate, then you want to look at some of the lunar geology books. So I'll highlight a couple of each of those. So the gold standard for the kind of lunar atlas that a lot of people have been using for years was the Antonín Rükl's Atlas of the Moon. It was out of print for the longest time. It's recently come back into print from 2012, yeah, it might be 2012. The 7th edition is now available at shop@sky.com. That's a Sky and Telescope portal. And so now you can buy a brand new one if you want. I bought mine used. And here you can see a sort of a sample of what's inside. The moon is broken up into, map sheets. And then these are drawn and painted by the folks at Antonín Rükl's team. So it's really a neat thing to have at the eyepiece. Now, unlike an app, you can't flip the view to match your telescope, but if you're using a Newtonian telescope, you just turn the book upside down and read the labels upside down, and that'll work. That's one way of doing it. The other way of doing it, though, is to try to get your hands on this. So this is Fred Dase's 2001 Lunar Field Atlas series, and he took images from the Consolidated Lunar Atlas and stitched them together by hand. He produced 38 labeled charts and all kinds of labels. You got thousands of objects labeled and indexed. And his website, he used to host it on his website for a download. The website's been taken down, maybe retired, maybe passed away, I'm not really sure. But you can still find the contents using the internet's Wayback Machine. And here's the link. When you go to that link, you'll find his page archive, and you'll find links to the PDFs. And what he did is he made a version of that atlas for each type of telescope. So there's an erect image for binoculars. There's a mirror image for refractors and Schmidt-Cassegrain. There's an inverted image for Newtonians. And then there's an inverted mirror image. I'm not sure who would use that, because I actually have all four, but I think I only need the 3 of them. And here's how that looks. So unlike the painted view of the moon, you've got photographic views of the moon, and everything's labeled up. So this is great. So when you do the things like the Isabel Williams program for RASC on the log sheets or the guidebook for the program, they do have the links to the pages or the chart numbers for Antonín Rükl's atlas. But when I set out, I actually added in the chart pages for Fred's pages as well. So I kind of used both. And there are things that appear in one and not the other, some of the detailed things, but it's a great resource. So I recommend that. Here's another one that's fantastic. It's out of print, I hear, but if you can find a copy, or maybe your local center has a library that has this, it's a great book by Paech and Weigand and Dunlop. And it's a photographic atlas of the moon. It's not the moon comprehensive, the full surface, but it's selected areas that are of high interest. And what's great is that it's got photos of selected features at a variety of illuminations, so at different times of the lunar month. And I read it page cover to cover. I did find some errors in it, nothing too serious, but kind of gives you a sense of how it looks. So I guess this is, not sure if this is Magnus maybe, or Tycho. Yeah, I think this is Tycho at different illuminations. So full moon, and then sort of first quarter, third quarter, different time. So it's a great way of seeing the feature at different times of the lunar month. And also it gives you some neat things to look for when you're viewing the object at different times of the lunar as well. Now this one, I can't recommend this book highly enough. Charles Wood, Modern Moon, A Personal View, really highly readable book. It again goes through different sections of the moon that are significant or more interesting, and kind of describes them, their geology, their history, how they're put together, what you're seeing and why you're seeing it. And it's really a terrific book. So, and my favorite tidbit in this book, I learned about Bill Hartman's hemisphere projection technique. So from the Earth, we can only see, basically 50% of the moon's surface, the half that faces to the Earth. And due to libration, we can add, about 9% more of the moon if we get the timing right. So you can see at times the North Pole, South Pole, east side, west side. So when we wanted to figure out what was happening around the edge of the moon that we couldn't see before we had spacecraft going there, what Bill Hartman did is this cool thing. He took photographs of the moon taken from the Earth and projected them on a white globe. And then he could walk around the globe and view lunar features as if he was orbiting the moon. Like, obviously couldn't see things on the far side, but a lot of these lunar features near the moon's limb suddenly made sense. So things like Mare Orientale, which we see kind of a dark sort of a streak on one quadrant or one section of the moon's western limb. When he did this, he said, that's a ring, that's a lunar basin. And so it was really a revolutionary way of learning about the moon before we could actually send spacecraft up there. So I think that was a genius idea. So here are a few books that I recommend for learning about the moon. This one's kind of got a foot in both worlds. The Alan Chew's Photographic Moon book. This is a free download from his website. It's very detailed. There are sections on the lunar formation, lunar history, lunar geology. And then again, he has an atlas element to it where he's taken photographs, all with a Newtonian telescope view. So all his images are all flipped already. So they'd match what you'd see through a Newtonian telescope. This one, the Lunar Source Book, this is actually put out by the Lunar Planetary Institute. So it's a public domain publication. So it's a source book, A User's Guide to the Moon, is a free download at this link here as well. Lots of information about the moon. Don Wilhelm's Geological History of the Moon. This is viewing lunar science and evolution based on both photographs of the moon from the past and also lunar sample analysis. And that's another free download from Arizona State University. So there's another link there. And then he also has another one called To a Rocky Moon, A Geologist's History of Lunar Exploration. And that's links more closely to the science behind the Apollo mission. So the planning of the mission, the carrying out, and then the return of the analysis afterwards. So in terms of apps, the one I use at the eyepiece all the time is this one called Lunar Map. And I actually use the Lunar Map HD version of it, which is about, I think it's about $2 Canadian. So I highly recommend it. This one's for Android, and there's one called Moon Atlas that I think works on iOS for iPhones. I haven't used it, but it looked like it had much of the same functionality. This has got the lunar map has a real-time terminator line. So you're actually seeing the whole moon all the time, but they draw the terminator line on it. It has the ability to flip the display for different optics types. So binoculars, Schmidt-Cassegrain, Newtonians. You can display different lunar maps, and you can zoom in and you can control how detailed the labeling system is. So this is really great to have on a tablet, a bigger format beside the telescope. I mean, obviously, there are other ones. I'll mention another couple here in a minute that you can have with your laptop beside the computer as well if you wanted to. My only complaint is that you can only use it. It's only showing you the current moon. So you can't kind of preview tomorrow night or, I mean, the moon's the moon. The whole moon disk is shown. It's just the terminator line is going to be for the current time, not tomorrow night or last night. SkySafari Plus and Pro are great. They have nice moon maps and nomenclature on those moon maps. The basic forms of those apps are a bit less powerful, so the moon map isn't quite as high res. The nice thing about them is that you can set the app to any time, so you can review what you saw, you can preview what you're planning to see, You can flip the view for your optics. You can add field of view circles to get a sense of how big things will look in the eyepiece. And I did find their nomenclature, their labels a bit too busy for my taste. This is a great one to have by the eyepiece as well. The moon map in these is, there's a limit to how much you can enlarge it. And the terminator shading can be a little bit inaccurate. So you'll be able to maybe see better than the app is showing in real life. Stellarium, the Stellarium Mobile, the Stellarium for desktop that we always use all the time in Insider's Guide. It came out with the version 23 and beyond, has recently improved its moon map quite a bit. So it even correctly displays the lunar X and things like that in the more recent versions of Stellarium. So I highly recommend upgrading if you can. On that one, you can also turn on and off the labels. Once the labels are displayed, you can search for lunar features. It's really powerful. And Blake Nancaro and I have worked to produce Stellarium bookmarks and SkySafari observing lists for the RASC programs, but not the Isabel Williams. It's a bit too many to do for that. And here's just what SkySafari looks like. So you can see it's pretty busy. And you can see the terminator is a little bit not distinct. So another, finishing up, another great tool here is Moontrek. So NASA puts out Moontrek, works on your laptop, or if you wanted to have a tablet and a browser open, you could do that. So there's the link. And you can work it as a flat map or a 3D globe, and it's got almost unlimited details. You can zoom in, zoom in, zoom in, because it's using orbiter imagery for that. And then the moon phase and libration tool that NASA puts out every year is at this link. And for that, you can type in any hour of the year using either the current time or the UTC or GMT. And that's great for previewing lunar X and things like that. And you can also, once you've got an hour you like, then you can actually click on it and it'll download a high-res labeled version of it. And there's a version of this page where you can get Newtonian telescope flipped versions of the same thing. So I'm going to stop there and see if anybody had any questions.
Somebody was asking if the moon had iron on it, and if they were paying attention, you were mentioning iron and titanium, but yes. But they're also asking about the magnetic field of the moon, and I put a link in there for Wikipedia's page on the moon's magnetic field. The short version being they don't really think it had a dynamo that give it an effective field in the early days, and it certainly doesn't have one now, but they have got some magnetic field measurements, and you can check out the article for that. It's very, very weak.
Yeah. So obviously the dynamic iron core of a world, of a planet or a moon for that matter, can generate a magnetic field, but an object as small as the moon is, I think the moon could fit, the edge of the moon would fit across the continental United States or Australia, that sort of thing. It's not as big as you think it is. So an object that small, the core cooled off a long time ago, so that killed the magnetic field. So we may find, we will find, I'm sure, rocks that are magnetized, that were magnetized if they formed early in the moon's history when it still had a magnetic field, but nowadays, nothing really to speak of.
Yeah, the Apollo astronauts did find it, but they're very faint traces of what used to be.
Cool. All right, any other questions? What do we got?
No, I put all the links for all of those things you've been talking about in there for everybody.
So I'll just mention a couple more things, and then we'll leave our time for the finest NGC targets. Obviously, the bright moon can ruin or spoil the show for meteor showers. And if you haven't already been aware of this year's Perseids Meteor Shower on August 12th, 13th overnight is effectively going to be moonless. So on that night, the moon will rise. Let's just pull this up here. Let's advance this up to the 13th. There we go. Back a little bit. There we go. So you can see there's no moon in the sky yet. So all the evening of the 12th, you can start expecting to see lots of meteors on the evening of the 12th. The shower will peak after midnight or so when the radiant is nice and high. Let's see if I can bring up the radiant here for the Perseids. Here we go. So that's the radiant for the Perseids, kind of climbing the northeastern sky in the middle of the night on the 12th. And then the moon is not going to show up until here. So the moon will rise around 3 a.m. And even though meteor showers tend to be best in the pre-dawn hours, when the radiant of the shower is nice and high in the sky, I think there's plenty of time. So that'll be a great, really great weekend for the Perseids. The evenings of the, even 10th, 11th would be great as well. And then the few nights after, but peak night is going to be really good this year. So get out of the city if you can, find some open skies and just lay back and enjoy the show. All right, what else we got here? A couple other things I'll just highlight. Just going to mention, see if I can bring up my bookmarks here. So I'll just do this by hand. So we'll go back to the next few nights. So we've got on August 3rd, 4th. Let's take this to the evening sky. Go, and we'll go to the 3rd. Here we go. So that night, you can watch the moon occult late night. So we'll just bring this up a little bit later. There we go. So these little stars named Psi 1, 2, 3 in Aquarius. Sorry, it's a little bit slow here. Here we go. This little group of stars, Psi 1, 2, 3 Aquarii, are meant to depict, I guess, the falling water out of the water bearer's amphora or his jug, that sort of thing. And you can see here that on the night of starting late night on the 3rd and heading into the wee hours of the 4th, the moon is going to occult for various parts of North America. Think about east of Winnipeg. You can watch the moon occult the top two, Psi 1 and Psi 2. So I'll just sort of zoom in here a little bit, center this up and highlight that. Now it is a late night event, if you don't mind. If you live, in the central time zones of Canada, then it's before midnight. But for us in the east, it's going to be a late night event. But we can see here if I advance the time. So the leading edge of the moon will cover the stars first Psi 1, then Psi 2, and then a little while after that, Psi 1 will reappear from the dark side of the moon, and then Psi 2 will come back as well. Then we've got another event on the 24th, and I'll just set this back a couple of hours. Set this to the 24th. Will it work? Here we go. The moon's going to occult Antares, and the moon's going to actually occult Antares a few times, or at least pass close to it, depending on where you live this year. So this is actually a little tricky because there's kind of a sweet spot in southern part of Canada where there'll be times where the moon and Antares are kind of setting during the event, and other times where the sky is getting brighter. But this is for Toronto. You can see here that on the 24th around 9:30 p.m. And if I advance the minutes here, we can watch Antares disappear around a little bit after 10:30. And then what I'll have you remark is, if you, depending on where you live, what you want to look for, you can preview this in SkySafari or Stellarium or some other app, is see how the moon's getting squashed, because in Toronto, it's going to be setting around that time. But if I go to, say, Winnipeg, it'll be nice and high in the sky. What you want to do is you want to preview the event and figure out which crater the moon is going to reappear, the star is going to reappear near. And in the case of Toronto, it's, I think, what did I say, Ennis. But in other places, it would be Stevinus, that sort of thing. So that's a great way of figuring out where to aim your telescope to see the star emerge from behind the moon at the end of the occultation. So you can see here in Toronto, they'll be setting. It won't be great, but Winnipeg and other places will be good as well. Let's see. September 27th, the moon's going to occult the amphora stars in Aquarius again. And then on the 14th of November, here we go. I'll go back to the 14th. See if this will work. No. Go back to here. There we go. The moon is going to occult, the young moon, crescent moon, is going to occult Antares in the daytime. So I don't know if anybody would be wanting to give that a go, whether you could see Antares in the daytime through a telescope, a decent sized telescope. Anybody seen it? But the moon will be tough to see, but the star would wink out and then come back if you can see the star through your telescope, maybe with a go-to system. Again, be really careful. The sun is only about 19 degrees away. So you want to be very, very careful that you don't put any optics towards the sun at all. If you've got kids involved, make sure there's adult supervision at all times, and always check to make sure that there's no sun entering the objective of your telescope before you look. So wave your hand over the eyepiece. Make sure there's no sunbeam coming out of the eyepiece before you look, whenever you've got a telescope out during the daytime. I'll stop there. I'll just move on to the finest NGCs here. So the summertime is great because unlike the spring where it was time after time after time, more and more galaxies, galaxies are great, but after a while, we need some variety. So the summer gives us variety in the finest NGC list. There are fewer of them, but more variety, as I said. And of course, tonight's a full moon, so this is not the night to be chasing finest NGC objects, but I'll highlight them and give it a week, and then we'll get to our third quarter moon period beginning, and it'll be great times to look at the deep sky objects of the summer. Let me just set this to a nice time like 10:30, and I'll just advance a few days. Just pretend there's no moon around. There we go. And here we go. Let's bring these up. And I've got some bookmarks. Here we go. So there's some really cool objects in this list. So first of all, we've got the summer Milky Way coming up from the southern horizon. And all of our objects are going to be kind of Milky Way related objects. First up, we've got my list here. We've got the Snow Globe Nebula, or Ghost of the Moon Nebula. And the first time I saw this, I was blown away. I thought, oh, that's cool. I was not unaware of it before. That's NGC 6781, and it sits here in the northern wing of Aquila. And I'll just zoom in here a little bit. And it's not this bright in reality, but I'll bring up the digital sky survey image of it so you can sort of get a sense of it. There we go. And in doing some research, what's neat about this, it's a planetary nebula, and it's probably kind of a cylinder of gas that we're looking down. So the most concentrated gas sections are on the perimeter, unlike, say, the Ring Nebula, which is more of a spherical object. So this is thought to be kind of a cylindrical object that we're looking down the center of. It's pointing in our direction. It requires a medium and larger aperture telescopes and dark skies to see well. It's not as bright as it looks like on the Stellarium here. It was discovered by William Herschel back on July 30th of 1788. So it's number 743 of his class 3 objects. And as I said a minute ago, it's easily located in Aquila. I'll just put this stars back on here so we can see where it is. So when you're looking at Aquila, you've got the summer triangle up here with Altair in the corner of it. You've got Almazan, which is the kind of heart of the eagle. That's the star Delta. And then it's about, on the line. This is just barely off the line joining Delta with Ocab or Zeta Aquilae. And I think it's about 37% of the way along the journey. What you can also do is for cross purposes, you can kind of look at Altair and look at the star Allia, which is in Serpens, and you sort of know that the snow globe is on the line connecting them and on the line connecting these two. So that kind of gives you that sense. In a telescope, that's how big it would look in a 6-inch Newtonian using a 26 millimeter Plossl telescopes, Plossl eyepiece, so it's not that large in that view. But this one's great if you've got an oxygen 3 filter or a UHC filter that'll brighten it up for you. And what you want to do is magnify it and start kind of looking at the size, the shape, kind of get a sense of how the brightness varies around the clock as you go around the edge of the nebula, and see if you can see the central star. You know, planetary nebulas, many of them have central stars that are observable. Not sure if you will, but take a look and see. And this one's about 3,100 light years away. All right, next up. So next up, we're going to hop up here to Vulpecula. So heading, you know, on the edge of the summer triangle, inside the summer triangle a little bit, there's Albireo, just for reference. So NGC 6802 is a cool little open cluster, and it's right at the tip, at the end of the coat hanger asterism or cluster. So there's the line of stars in the coat hanger, and then the hook of stars below. I've got the stars a little bit over bloated here, a little bit brighter than they really look, but that's the cluster there. And so if you can find the coat hanger and just look to the eastern end of it. So this star cluster can be seen in any size of a telescope, but if you've got more than 100 millimeters of aperture, you're going to have the best view of it. Discovered by William Herschel back on July 11th of 1784, number 14 of his class 6 objects. And as I said, the coat hanger sits basically between Altair and Vega, a little less than halfway. So if you pick that up in your binoculars or your finder scope, then you can easily zero in on NGC 6802 at the end of it. And in a telescope, it doesn't look like much here. Let me just bring up the digital sky survey image and turn off the stars here. So it's kind of a brighter patch against the background stars. If I actually make it a little bit bigger, let's go with a 14 millimeter Plossl. There you can start to see it's kind of it's not a round cluster. So what you want to do is start with, say, 50 power, maybe a little bit more. Try to see the faint cluster. It's actually framed by kind of a box of field stars. That's kind of cool about it. And some of those are doubles. You can see there's a couple of pairs in here. So that's neat to note. Then sort of crank up the magnification and start looking for how many stars there are in the cluster. What shape do you see? All the stars varying. Do the stars vary in color? What kind of color stars do you see? Things like that. All right, next up, we've got kind of a 2-for-1. So this is actually the Veil Nebula. Just bring up the stars here. There we go. And we'll go back to the full sky. There we go. So if you're looking at Cygnus, and you can find Deneb and Saturn, the two main stars in the center of the cross shape, his lower wing extends downward. And near that lower wing, you can count 1 star, 2 stars. And if you sort of rewind your steps and look to the west, to the right, there's a medium bright star, naked eye star, called 52 Cygni. That's visible with just your eyes. If you aim your telescope at that star and zoom in, then you're going to pick up the supernova remnant called the Cygnus Loop or Veil Nebula. There are different names for it. This particular piece of it is called the Witch's Broom. So it's sort of the 52 Cygni is the witch sitting on the broomstick with the straw kind of near the bottom. You can see the whole nebula in binoculars if you get out to dark skies. So that's kind of cool. And then you can use your telescope to zoom in on sections of it. So when you zoom in, you're going to see this sort of swath of brightness, nebulosity crossing through the star. Then you're going to be able to sweep around and trace out the extent of it, north and to the north and to the south. UHC or oxygen 3 filter will be a great way to reduce the impact of 52 Cygni and any other of the field stars around it and really make the nebulosity stand out. If once you get used to the idea, you can then start sweeping around the loop. Try to follow your steps around the loop. If you decide to start at 52 Cygni again, you can go straight across and then look for the other half. And the other half is the next finest NGC in the list. So this is NGC 99A, and then the other half is 99B. The reason I've got them labeled as C here is that they're also in Patrick Moore's Caldwell list. They're Caldwell 33 and 34 on his list. So much the same idea. Now, if you want to, I would never probably look at the east half without already having found the west half. But if you did want to start with east half, all you need to do is take these two stars in Cygnus's wing, look about halfway between them, and then it's about a degree to the west. So that's another way of kind of aiming your finder scope. Pick up those as well. This is arguably a little bit brighter than the Witch's Broom section. So that's kind of a neat one to find. It doesn't sort of stretch quite as long. But, you know, when you're looking at these sections, you want to observe the orientation, the shape, the size, maybe sketch. This would be a great object to spend some time sketching. And yeah, just enjoy this whole supernova remnant. They think maybe happened about 5,000 to 8,000 years ago. And this is the remains of it. And it's about 1,475 light years away from us. All right, let's go back, pick up a few more of these. So the next one I've got here is the Mothra cluster. That's NGC 6940. And it's actually pretty close to the Veil Nebula or Cygnus Loop. So 6940 is here. This one is sitting in a relatively rich part of the Milky Way. Again, I'm going to switch to the DSS image so I can show you how it stands out against the background. There we go. So you can see the whole, you know, the Milky Way enriches the background star field with a population of faint stars in the background. But you can see this sort of condensation bright patch here. And if I put it in the eyepiece, and I'll just wind the magnification. You want to go down, start with low magnification on this. So this one is, as I said, it's about 3.3 degrees from the 52 Cygni star. So let me just kind of come back out for a second here and show you. Have those stars back on. And what I remarked is that you could take this and you could aim your finder about midway between Gamma Delphinus, so the nose of the dolphin, and Saturn, the bright star in Cygnus, and it's on that line connecting the two, almost near the middle. So that would be a way of starting with low power and kind of using that trick to find the object. You want to note the cluster shape, the number of stars you see, the patterns of bright and dark, and any anomalous star colors that you might notice. And then you can zoom in and see if you see any little mini asterisms and star patterns inside. It's about 2,600 light years away. All right, we got two left. Next up, I thought we'd go up to the Foxhead cluster, NGC 6819. So that you can see here is in this triangle in the upper wing above Saturn. This is a small but pretty rich open cluster superimposed against the background of the Milky Way. And again, I'll kind of reveal that here. You can see it's much more concentrated, much more contrast against the background Milky Way. And it's got some really nice field stars accompanying it. So that kind of makes it nice and easy as well. You can see this cluster in big binoculars, 10 by 50s if the sky is dark. Any size of telescope will work great. This one was actually discovered by Caroline Herschel on May 12, 1784. And then later on, William viewed it as well. And other people as well logged it and sort of discovered it. So this one actually doesn't have a Herschel designation. So it's out of the mix. As I said, it's located about, just bring this back to here. Let's just do this. So it's about a thumb's width from the midpoint between the stars Eta Cygni. So Eta Cygni is in the neck of the swan. And what did I pick here? Oh, not that. Yeah, let's see. And Phawaris. So yeah, if you pick up Phawaris and Eta Cygni, it's kind of above the midpoint of the two. You could do it that way. You'll also notice that it's bracketed by a couple of brighter stars here as well. So 19 Cygni. So here's 19 Cygni here and 14 Cygni. So you'll be able to see those in binoculars for sure, and maybe in a finder scope, and you'll be able to spot it about midway, a little bit to the west of those two. I thought this was really interesting in the eyepiece. You want to start again at low magnification and zoom in, of course, and look for the, I thought it resembled a bit of almost like a globular cluster when I viewed it in my scope. So count its stars, note its shape, look for patterns, many asterisms, note its density, and stars that are not like the others. This one's about 6,700 light years away. Last up is a really neat one. It's the Crescent Nebula. And the Crescent Nebula sits on the neck of the Swan. So there's Alberio off to my upper right here. There's Saturn in the heart of the Swan. There's Eta Cygni on the midway along the neck of the Swan. So it's really along that line, really easy to aim your telescope at it. This is a concentrated emission nebula. There we go. It might be a supernova remnant. I've seen reports that talk about both. And what's neat is that it's got more intense, brighter sections of it that can actually be picked up in big binoculars under dark skies, and definitely in any size of a telescope. But if you've got a big telescope, bigger aperture, you'll be able to pick up lots more details and lots more cool aspects of it. It was discovered by William Herschel on September 15th of 1792, number 72 of his class 5 objects. And yeah, it's about a third of the way from Saturn to Eta, as you can see here. This one works great with a UHC filter or an oxygen filter. Again, don't over magnify it. So if I go to the simulated view, that's the sort of 65x view here. No, that's the 35 power view. So that's the lowest magnification I've got set up in a 6-inch Newtonian. So you can see it's quite substantial in size. But you know, start with the overview, note its shape, note its structure, look for the field stars around it, and also it's actually got a Wolf-Rayet star in the center of it. So that's the one that's kind of shining here in the middle of the symbol. So you want to take a look at that. And if you've got a larger aperture telescope, you can start looking for the irregularities in the gas. So this one's about 4,700 light years away. And that's it for this time. We only have one more short set of finest NGCs, and then we've done them all.
Fabulous. We had someone asking a question that I'm going to attempt to answer, which is, is it true that the full moon has effects on mental health? Well, I used to be in the mental health emergency services unit of the Vancouver Police, and if anything that interferes with people's circadian rhythms, like too much artificial light from the neighbor's house or whatever, will all have effect on people's mental health. So obviously, very bright nights with a full moon can as well. I don't think I would go so far as to say that we had extremely busy nights when there was a full moon because people got crazier, but it did definitely have an effect on people.
Yeah, yeah. And there's a lot of anecdotal stories around it too. If you ever get a chance to research the Maori teachings about the moon, they actually fully believe that the moon affects human moods and behavior, and they actually kind of like look out for each other. You know, people tend to maybe be reckless at the full moon and maybe be depressed at the new moon, things like that. So it's a really fascinating thing to read up on if you ever get a chance to look into that.
That's true.
Nice.
Also, I thought that if I just spotlight myself here for a sec.
Sure, I'll stop sharing.
That's the Witch Nebula behind me there.
Yeah.
One of our
That's like one of those Easter eggs. Now you have to go watch the program again from the beginning.
Erwin Dieter, one of our oldest members, took this picture with his 16-inch telescope. It's quite an impressive sight. It's
not that the finest NGC are not, you know, primary targets, but it's kind of strange that it didn't get more famous, right? Because it's really easy to see in a dark sky. And it's a really great outreach target, really good. Nice.
All right. Somebody was asking about the observatory that was supposed to be part of the show this week. Can you tell them when that's going to happen?
Yeah, so I had reached out to York University. They recently installed, a few years ago, installed a much bigger, more modern telescope. And York University and here in Ontario are really big on astronomy outreach and train their students in that. And they do lots of public viewing and live streams and tours. And I thought that would be a great thing to do in the summer. And so I set it up with the director to have us go live today. But it turned out that they were going to do some renovations during the school off season. And they discovered some issues that would have made the observatory unavailable this week. So we just traded. So we're going to do it next time, end of the month. Yeah.
Thank you. Okay, well, it doesn't look like anyone has any further questions, so I think we're done for the day. Thanks, everybody, for coming.
Excellent. Well, get out there and look at the full moon tonight. It's going to be lower in the sky than you might think, so you may need to walk around and find it. But
smack in the middle of the teapot at when I was looking on Saturday night.
Yeah. So, but it'll be there. It'll be bright. If you're up late at night, it'll be shining in your windows. So enjoy. And we'll see you back in a month. We'll wrap up Finest NGCs and we'll be live at York U. Fingers crossed that it all works well. See you then.
All right. Keep looking up, everybody.
Keep looking up. Bye now.